Today I'm going to show you how I went about solving exploit 15 succession found here on the Solidity challenges repo. So if you haven't already, clone the repo, open it up in your editor. Over on the README, it states you've inherited a fortune, but there's a catch. You can't claim until you're 25, or can you? So our mission is to find a way to claim our inheritance before the age of 25, bypass the age restrictions set in the contract and unlock the tokens, and then they give us a test command to verify our exploit. Over on succession.sol, starts by importing a couple of OpenSetLink contracts, it inherits them. We have a constant, which is the claim age of 25 years, and a state variable for the birth date. In the constructor, it takes the address of the successor and the birth date. The ERC20 is initialized, ownable contract is initialized, birth date is set in state, and then they call mint. You'll notice the successor, who's us, will be minted the tokens, 1 million tokens that is. There's a modifier, is old enough, simply requires that 25 years has passed, and then we can claim our inheritance. When we call this method, we have the ability to pass a recipient address. It has to pass the guard, is old enough, and then the transfer occurs. So it'll transfer from our account to the recipient account for the balance of this contract. Now, the transfer itself has been overridden. You'll notice that it now incorporates the is old enough guard. So this is to prevent us from being able to call it at any given time. So in order to get past the age guard, we actually have to know a little bit about ERC20. We do have the ability, obviously, to transfer tokens, especially ones that are assigned to us, but we can also have others transfer tokens on our behalf. So what we're going to do is bypass this contract completely. We're not even going to call claim inheritance in order to get our inheritance. We're going to use another method, transferFrom. So I created this attack contract. It's more of a hack contract. I call it hack here. And we are going to use the ERC20, and we make an instance of this succession contract. We'll have a function called hack that will literally call transferFrom. We're going to give approval for this contract to transfer tokens on our behalf. So they'll transfer our tokens to this contract. We are going to have control of this contract. So again, it's not an attack contract per se, but it is a hack for sure. So we will allow this contract to transfer all tokens on our behalf, bypassing that contract completely and the 25-year guard. All right, so let's move over to the test. You can see here that I've imported the hack contract. We have instance of succession contract, the challenger EOA, contract's balance of 1 million tokens. In the setup, we define the birth date just as a block timestamp. Here, succession contract is deployed with the challenger being the successor and then the birth date being passed. They prank us as the challenger up here. There is a pre-check to make sure the balance of the succession contract is indeed 1 million tokens. And here's where they'd like us to do our test attack. So we deploy our hack contract. Remember that we are currently pranked up here in the setup as a challenger. So we are the owner of this contract. Then, still as the challenger, we call succession and we approve the hack contract for the whole balance of the challenger. You gotta remember, all those minted tokens were minted to us. Right? So the whole balance of that contract is going to be approved to allow the hack contract to transfer it on our behalf. Once that's all said and done, we simply call hack. The assertion we need to pass is that the balance of the challenger is now 0. So this is on the succession contract. So we have indeed removed our full inheritance from the succession contract. All right, so let's move over to the terminal. We can see this in action. I already have the test command loaded. So from the top, you can see our test attack. We create a new hack contract. We end up calling balance of a couple times here. So if we go back, you'll notice, say, right here in the test, in the approve method, before the approve is totally called, one of the parameters is the balance. So we're actually calling balance of here. And you'll notice again, in the attack, when we run transferFrom, as a parameter, we're actually first reaching out to the contract, getting the balance of here also. So when we're back on here, when you're reading this, you'll see a balance of. That's what that's referring to. So we need to get the balance of as a parameter. We then called approve. We approved the hack contract to spend the 1 million tokens on our behalf. So the approval was emitted. It was true. And then again, when we on our hat contract, we're now doing the transfer from. This balance of is a parameter needed. So we're going to transfer 1,000,000 tokens, and we can see that here. Again, from us to the hat contract for 1,000,000 tokens. We emit the event. And then the final balance check checks that the balance here of the succession contract is indeed 0. And we run our final assertion. All right, so that was my approach to this challenge. I believe there probably is another way of going about it. That was the easiest way, first thing that came to my mind when I saw it. So I'd love to hear your approach, or if you simply want to talk about my approach, you can grab my contact information in the details below. See you in the next one.